Hello class, this is Mrs. Gallegos, and today's tutorial will be on drawing Lewis structures. This can be found in topic 4 of your textbook, section 3. What is a Lewis structure? A Lewis structure is the brainchild of Dr. Gilbert Lewis, a chemist who lived in the beginning of the 19th century and taught and did research at Berkeley. This is the Lewis structure that he came up with to describe covalent bonding. He is also known for describing a different form of an acid and they are an acid and bases, the Lewis acid and the Lewis base. A Lewis base donates a pair of electrons, you can see in green, and a Lewis acid is defined as one that accepts the electrons. He was found in his laboratory after working with some hydrogen cyanide. So here's the Lewis structure of hydrogen cyanide. So what do Lewis structures show us about covalent bonding? They show us the location of the non-bonding electron pairs, and there they are, they're represented by dots. And they also show us the location of the shared electron pairs. Now here we're not going to see two dots, but instead two electrons will be represented by one line, and this is important to remember. And so the Lewis structure shows us the areas or the domains where we can find electrons, and they will either be bonding or non-bonding electrons. So how do we draw this Lewis structure? So the first thing we're going to do is we're going to add up all the valence electrons that are available to bond the atoms in a molecule. So for example, if I have water, H2O, I'm going to have one valence electron per hydrogen, times 2 will give me 2 valence electrons contributed to the molecule by hydrogen. And then oxygen, there are 6 valence electrons in one oxygen atom. And since there's one oxygen atom in water, we have 6 valence electrons donated to bonding by oxygen, giving me a total of 8 valence electrons. Now that I know how many valence electrons are available for bonding, I want to connect all the atoms with straight lines, and these straight lines represent a shared pair of electrons. So one line equals 2 electrons. So here I have my oxygens and hydrogens, and then here I have my bonds. Now I've used up these electrons in bonding, so what do I do with the other electrons? So I have 2 electrons in one bond and 2 in the other for a total of 4 bonds. 4 electrons used in bonding. So what am I going to do with the other electrons? So I'm going to subtract the bonds that I used in bonding from my total number of valence electrons, and I'll find I have 4 leftover bonds. And I'm going to place these bonds on the atoms so that they all have an octet. So I'm going to place the 2 leftover pairs on oxygen, and as you see, I have an octet now of electrons around oxygen, 2, 4, 6, 8. Now remember, hydrogen is one of our exceptions to the octet rule because it's in the first row of the periodic table. The noble gas whose configuration would represent an octet actually only has 2 electrons, helium, so hydrogen only has to have 2 electrons around itself. So the next thing, guided practice. Go ahead and stop the video and see if you can draw the Lewis structure for NH3 ammonia. How did you do? So first you should have totaled the valence electrons and discovered that you had a total of 8 valence electrons, 5 from nitrogen and 3 from the 3 hydrogens. Next you should have connected the 3 atoms with a straight line representing 2 valence electrons. And then you should have totaled up all those bonding electrons and subtracted them from the total number of electrons, valence electrons that we have in bonding. And you should see that we have 2 left over. And then you should have taken those 2 and put them on the atoms so that all of them have an octet. And so now we're going to verify that there are octets. Hydrogen has its duet, let's call it, 2 electrons. Nitrogen has its 2, 4, 6, 8 electrons, hydrogen has 2, and hydrogen has 2. So this is a correct Lewis structure showing bonding in ammonia, NH3. How'd you do? All right, so some compounds we discover will have double bonds, And so again, we calculate the total number of valence electrons. Carbon has 4 valence electrons. Oxygen has 6 times 2 gives us 12 valence electrons for a total of 16. Next, I connect the atoms with straight lines. And then I have 4 bonding electrons. Subtract that from 16. I have 12 left over. Now I'm going to put those leftover electrons on my atoms. Yikes! Both of my oxygens only have 2, 4, 6 valence electrons around them. So this is not a correct Lewis structure. So what can I do in order to get everybody an octet? Well, what I'm going to do is I'm going to take an electron pair and I'm going to convert it into a bond in between the carbon and oxygen. And now if you look, my oxygen has 2, 4, 6, 8 electrons around it, and so does my carbon. Now I have to go deal with the other oxygen. I take that electron pair, convert it into a bond, and now if you count, I have 8 electrons around each of my atoms, and that is a valid Lewis structure. Now, we can also draw structures of the polyatomic ions. Remember, polyatomic ions like NO3 nitrate are covalently bonded because they're 2 nonmetals. However, they have an overall charge, meaning overall they have either an extra electron or a missing electron, but we'll follow the same rules. So first I count how many valence electrons I have. Nitrogen has 5, 3 oxygens have 18, plus I have one extra charge from my oxidation number, so that gives me a total of 5 plus 18 plus 1, 24. Now I just follow the rest of my rules. I connect my 3 oxygens to my nitrogens with a single bond. I total up those single bonds, 2, 4, 6. Subtract them from 24. I have 18 electrons left over. So I'm going to put them in pairs around each of my atoms so that I will have octets for everybody. Oxygens all have an octet, but if you look at nitrogen, it's 2, 4, 6 electrons, not an octet. So as you know from the previous example, I'm going to take one of the electron pairs and I'm going to use it as a double bond. And so now I see that all of my atoms have octets around them. Now with polyatomic ions, I'm going to do one extra step to show that they're ions. I'm going to put the Lewis structure in brackets, and then I'm going to add the oxidation number on the outside. Now some of you might have been asking yourselves, I could have put that double bond in 2 other places. So I would like to introduce to you something called a resonance structure. It turns out that if you have atoms that can have the same atom arrangement but different electron arrangements, we call this a resonance form. And so when you draw the Lewis structure for a molecule that has more than one resonance form, you must draw all of the possible locations for the double bond. And so here are the 3 resonance forms for the nitrate ion. And we will practice this in class with other atoms or other compounds, other molecules. So to recap, in review, first thing I do is I add up all the valence electrons. And if I have an ion, I'll either subtract an electron if it's positive or add an additional electron if it's negative. Then I connect all the atoms with straight lines, which each represent 2 shared electrons. Then I subtract all the electrons and bonds from the total number of electrons, and then I place those leftover electrons as pairs around each atom in order to create an octet. Now remember, there are exceptions like hydrogen doesn't require an octet. Then 5, if there are not enough electrons, we make a double bond. And if there is more than one place to put the double bond, then I draw all the possible resonance forms, in addition to that one that I just drew. And then if I'm dealing with polyatomic ions, I'm going to remember to bracket the polyatomic ion, include the oxidation number outside the bracket.